Hi, section 2.3, measures of central tendency. We're going to turn these objectives into questions. How do we find the mean, median, mode? How do we find the weighted mean of a data set and estimate the sample mean of a group data? How do we describe the shape of a distribution? So measures of central tendency, those are going to be our typical mean, median, mode. I need you to write down that sigma x stands for that you're going to add up all the data entries. We're also going to write in the following. Anytime I read population mean, I symbolize it with mu. Anytime I see the word sample mean, I'm going to put down x bar. Or if I see x bar, I'm going to interpret that as that's the sample mean symbolization. Capital N stands for population size. We already know that lowercase n stands for sample size. So to find the sample mean, we have the weights for a sample of adults before starting a weight loss study. They're listed. What is the mean weight of the adults? We're going to add them all up and divide by the number of times, or the number of data values. But what I really need you to do is practice writing these symbols. X bar equals the sum of the data values divided by the sample size. So we know it's going to be 258.6 because we're able to do that in our calculator. It's the practice of the formulas, writing the formulas. So the median, there's things that I want you to highlight. First off, highlight that word ordered. The data has to be in order. For an odd number of entries, we're just going to pick the middle number. For an even number of entries, you've got to figure out what's the two middle numbers and take the average of those. Add them up and divide by 2. So when you see a list of data, you're going to have to first put them in order. Then you're going to have to pick the middle. So that's what the computer's got. You've got 7 entries, it's easy to pick the middle. It's 268. Let's say 285-pound person decided to not participate in the study. So what's the median of these data values? They're already put in order. We notice that the two middles are 235 and 268. We're going to add them together, divide by 2, and we get 251.5 pounds. So the mode is the one that shows up the most. Please highlight the words greatest frequency, because that's going to help us whenever we go to a frequency table. If no number repeats, it's no mode. And if a number or if 2 values repeat the same amount of times, bimodal. So looking at this next example, we can see that 235 shows up the most. That's the mode. Let's say you were trying to find the mode whenever you're given a frequency distribution. So political debate of a sample of audience members was asked to name the political party to which they belong. Their responses are shown in the table. What's the mode of the responses? The one that shows up the most is Democrat. So we would say that the mode is Democratic Party. Okay, comparing the mean, median, and mode. Which one's we're going to always use the mean in statistics. We think it's the best measure. Just be aware that there are outliers. Go ahead and highlight that word. So we've got this sample ages of students in a class. We're going to find the mean, median, and mode, and then discuss why we have each of these. So the mean, you add up all the values and divide by the number in the sample. The median, there's an even number of data entries, so you have to add the 2 in the middle and then divide by 2. And the mode, 20 shows up the most. The point of this problem is to show you that the mean is thrown off by that 65 being an outlier. And the mode kind of throws us off because it only shows, like 20 is only the beginning of the data. Like there's more data values that are after 20. So the median in this case would be the best measure. However, this example is just to throw some discussion out there. We'll always use the mean. If I were to see the histogram, you can see the gap. Okay, so weighted mean is going to be the sum of the products of each data value times its individual weight divided by the sum of all the weights. In your notes for this problem on the grading system assigns points and you determine your grade point average, you actually have a column in between final grade and credit hours. I want you to put the point values of each final grade in between there. So in the X column, be sure you put the point values, Realize that the credit hours are actually each of the weights. And now you're going to take the products of each row, 2 times 3, 2 times 4, and put them in that last column. After you find each product, you're now going to find the sum of each, or the sum of that column, which gives us 40, and you're going to divide it by the sum of the credit hour column. And we get 2.5 being the grade point average. In a similar manner, we're going to find the mean of a frequency distribution, and it's going to be approximated by taking the sum of each data value times its individual frequency divided by the sample size. If we don't have the sample size, just a little recall that sample size is the sum of the frequencies. We're going to follow these steps when we want to find the mean of a frequency distribution. We're going to find the midpoint of each class, then find the sum of the products of the midpoints and their frequencies. We're going to find the sum of the frequencies to figure out the sample size, and then we will use that formula we just highlighted to figure out the mean of the frequency distribution. In this case, you already see that we've calculated the class midpoints, we've got the frequencies, we've got each data value, or each midpoint times their frequency, and then I want you to highlight that we found the sum of the frequencies, which is the sample size, and the sum of the products. So we're going to take the sum of the products divided by the sample size to figure out the mean. And we get that the mean screen time is 287.7 minutes. And it is an estimate because it's based off of the class midpoints and not of the original data. We're going to do our last objective, which is to figure out how we describe distributions. So if you have histograms where, or just any graph, and you notice that it sort of looks like a bell curve, we call that a symmetric distribution. The mean, median, and mode are pretty much in sync. Uniform distribution sort of looks rectangular, where every entry shows up the same amount of time, or the same amount of frequencies. This is also technically symmetric. The mean and median are in the exact same spot, but since everything shows up the same amount, there's no mode. So then you have skewed left, meaning that the mean lies to the left of the median. And that also means that it means your data slopes off to the left. And whenever you are skewed to the right, that means your data slopes off to the right, and your mean is to the right of your median, and not everything syncs up. And that is it for today.